In this video, I'm going to give you a quick overview of the commercial LEAPWORK tool. This is a visual GUI block-based automated execution tool for helping teams create automated execution when they don't know how to program. And I'm going to show you the hierarchical modeling components and how to create subflows and build up flows to automate an application. And the application that I'm going to use during this video is the To-Do MVC application, because that's quite rich and offers a lot of scope for checking how well the tool works. And the aim is to give you some insight into the tool, some nuances for using it to help shortcut your evaluation process if you choose to look at the tool. My name is Alan Richardson. You can find me at eviltester.com, and this is a sponsored video because LEAPWORK have paid for my time to create the video. They haven't told me what to say. This is an independent overview, and you can find LEAPWORK at leapwork.com. So the main concepts in LEAPWORK are the hierarchical flows. This is a hierarchical modeling component. In here, I can expand this. I've got complete control over this. I can create folders, and each one of these is a flow. This is a flow that would represent an automated execution through an application, and I've got subflows which represent smaller components within there which are reusable and do things as part of the main flows. Flows are chains of building blocks, and each flow has a name and it represents the execution flow through an application. They're represented as diagrams, and each flow has its own visual representation so we can understand very quickly what the flow does. So this get to do at position X is a subflow. We can create our own subflows, and these are used as building blocks which allow us to create domain level abstractions to model our application so it represents exactly how we think about modeling this. Subflows are the basic way that we create abstraction layers, and flows are the basic way that we create test paths through the application that will automate on a regular basis to see if the application still does what we expect. So I'm going to create a very simple flow so that we can see how flows work. I'm going to add it into this paths folder because that's where I've got all my execution flows, and the hierarchy just makes it easier in the drop downs and in the lists to find the flows that we want to do. So I'll create a new flow. I'm just going to create a simple flow that opens the To-Do MVC app. So now I've got a blank page. I'll start by closing all the windows, and then what I want to do is use the web controls to open a browser. So I'll start the web browser, and I'm going to go off to http://todomvc.com. So I want to find an element on here. So I'll use the web, find web element, and I'm going to select the web element to find. Now what this is going to do is going to pop up a browser because it knows we're going to todomvc.com, and now you can see that the tool is monitoring what I'm doing in here. So I want to click on the vanilla.js version. Now if I have a look at this in the web element, we can see that the selectors are pretty flexible. I could completely create this from scratch. I could delete the existing things that are here. I can edit this. If there's multiple things returned, I can choose the specific version here. This is a key component in learning how to use the web functionality of LEAPWORK well. So this is something that we eventually learn how to use to create fairly complicated selectors. So I'm going to make this scroll into view. And then what I'll want to do is I will want to then click on this. So I'll use the web, click web element, and I'll want to pass in the web element that we found in there. Now one of the interesting things here is that this timeout is not a sleep, it's a wait until the web element is found and then it will carry through. Now I haven't connected this not found, so if we don't find the element, this will automatically fail. I could drag this off and choose a start stop fail, but I don't really need to because by default flows that are not covered will fail. So on the page, so I'm just now going to just check that the title is what we expect. So in the web, I'll get the browser details. Then there's the title. So I'm just going to pass that into a comparator, logic, compare, and I'll just copy the title from here. That's the title that I want. Paste that in there. And I can scroll in the tool by pressing space and move it that way. Then I want to make sure that the browser detail flows in. The green flows are the path through the flow. The blue flows are data flows. So having compared it, if it's successful, I will then want to say that we have passed this test. So I just click preview and make sure that this works. So this execution is finished and the history says that it's passed. And I can scroll through this and see exactly what happened as it was executing. I can see it's closed all the windows, run them. So we've got a history of how it worked. And at each stage here, we can see which block was being run. So it's a very simple way of creating blocks, connect them together, passing data through and having an executable flow out the end. So let's have a look at a flow that I created earlier. I'm going to look at the amend a to-do flow. This is a little bit more complicated. So this one starts up, closes all windows, starts the web browser, goes directly to the application. Then I'm using a bunch of subflows to create a to-do, amend a to-do, count the number of to-dos that are there and assert that there is one, then get the specific to-do at that position, get the web text from it and check that it's the value that we added. So the key to understanding this is that the green flows are the flow, the process flow through, and the blue flows are data. And making sure that all the blocks have got the green flows connected is how we know that our paths are going to work. So the data flows here are we get a specific position and we take that web element that we found, pass it into get web text. Then we take the text from that web element and pass it into the compare functionality. So again, this compare, when it's incorrect, doesn't go anywhere, so automatically fails. But I could make that more specific by putting any fail, start and stop. So now it's obvious that we start here, we flow through, we pass when the comparison works, and we fail when the comparison is incorrect. There's a lot of documentation on the LEAPWORK site. I found the easiest way to read it was to right click on one of the blocks and then read documentation, and that would take me directly to the website with the documentation for that specific web element, and then I can read the rest that's in there if I want to. But going direct to the documentation for the control was how I was using the documentation. Now I can click through into each of these subflows to see how it works. Some of these are more complicated than others, but this is how we build up abstraction layers to model our domain in the application and make it more maintainable. So this start a web browser here, I use this in pretty much all my flows. So this should really be a subflow. So let's create a subflow from this. So if I right click on what I've selected now and do create subflow, I'm going to call this start app. Now it's put it down here. I'm just going to move that into my actions, which is where I'm putting all my reusable components. So if I go into start app now, we've got start flow, then end the flow, which is the next bit. The names are important. I can rename these if I want. So here I'm going to start the web browser. Now rather than hard code this URL, what I'm going to do is I'm going to add in a place where I can have that variable. So I'm going to add in a variable and the get variable. If I expand this, you can see that the scope here says only in this case or schedule. So I'm going to make it schedule so that I can override this default value if I schedule the tests for different environments. If I haven't created a schedule, I'm just running this in preview, it will pick up the default value. Then I want to take this value and pass it in as the web address there, and I'll call this the app URL, and then I can set it as part of the scheduling if I want to later on. So I actually want to add the result value into the web address, otherwise it will always have the default value. There's the default value, I'd use that. The result value is if there's a value set, the schedule will use that, otherwise we'll use the default value. There's inbuilt version control in here, so you add comments for all your saving. So created subflow. If I go into amend, save that, added subflow. And if I preview this, it shouldn't make any difference to the execution. And this will work. It will create the to-do, amend it, and then we're done, and that should have passed. So if I go off to scheduling now, we can see how we can build a flow, and we could schedule this on an ad hoc basis or on a time-based basis, or even trigger it through continuous integration. So I'm going to create a new schedule here. I'll call this ad hoc amend because that's the one we're using. I'll schedule this to be completely ad hoc. Now here you can see in the flows to run, this is where all the flows we've got. So having it in a hierarchy makes it easy for me to choose which ones. I'm going to choose the amend a to do. And then environments, currently I've got this set up for localhost, which is going to run on my current machine. And I can then create the variable app URL. And if I make this https://leapwork.com, the test should fail. It will open up the browser and fail because we're not on the right page. So if I save that, we'll see whether we can override the values in the scheduling, which is what we're expecting now from that flow. And in the schedule now, if I run this as an ad hoc process, it should go off to the LEAPWORK site, and then the amend flow will fail because we're on a different website. But we've overridden the variable at the schedule level, which allows us to create defaults at a schedule level, but have values as defaults which can run as part of the main test. And having this test failed means that I can then look at the reporting, and we can have a quick look at the failure information that we get. So this is the test that we just ran, and we can see that as it comes through here, variable app URL was set to LEAPWORK, then we start Chrome, we click to do, and the element was not found. So we can see what the information there was. Now if I go back to scheduling and amend this so that it goes to the correct website. In fact, I'll just take out the app URL and we'll use the default. Then if I run this again, it will go off to the correct site and we've run the flow. So I could have a batch of flows, a suite of flows in here and run a bunch of different execution paths at the same time. That's what the scheduling is for. And there's an API so that we can trigger them via our continuous integration processes if we want to do that, or we can schedule them to go off at various times, whatever we need this to work. So this is a flexible way of automatically triggering your flows without having to set up a full CI environment if you don't have access to that. So if I go back to the flows in the amend flow, we've now got the start app as a subflow, but you can also see that I've hard coded in here the value that I'm typing in. So the same value is repeated here. It might be a little bit easier if that was controllable within the test. So I'm going to add a building block for set value. I'll set text, and we'll have that as the text that we've currently got in here. So I'll copy out the text that's there, paste it in, and then rather than have the text in there, what we'll do is pass in the text there, and the same text value will go into our comparison. So now I'm basically saying, get the web text, compare it with the value that we've defined here. The benefit of doing this is it could be set up as a variable, it could be coming from some other part, but I've made it more flexible in my test. The capture part here basically lets me put in special keys. So I've put in an enter key there by putting the capture in. Things that are hard to type, we use the capture for. So this means that there's less information to maintain. I've only got this in one place. It's a lot easier for me to change the test. And just gradually over time, you refactor your flows to make them more amendable, easier to maintain. One of the things I've realized working with LEAPWORK over this evaluation process is that gradually refactoring your flows to have more subflows, more data which you can amend from one place and not others, is the easiest way to make your execution flows maintainable for the long term. And it's also modeling abstractions so that your execution flows more represent the domain language that you use when you talk about executing the application. So I'm creating a to-do, I'm amending a to-do, rather than clicking on web text, finding web elements. It makes the test flows a little bit easier to read. So this tool is aimed at teams who don't necessarily know how to program, but still want to execute automatically their applications. So there are a lot of building blocks for common applications. If I add building block here, we can see that there's blocks for testing desktop applications, testing the web. There's a whole bunch of functionality you can do on the web. If you want to do image recognition, I can take control over the mouse and keyboard if I really need to get physical with the mouse and keyboard rather than just hovering over web elements. I can move to actual places and do right click and drag and drops. There's logic controls if we need them. I've mainly used that for the comparisons. We can do Datadriven that we'll cover later on. You can get information from HTTP requests. There's a whole bunch of stuff in here that's pre-canned. The Datadriven is interesting because there's an HTTP request one, so if I needed to call HTTP APIs, I can do that with the HTTP request. If you do have programming, then the command line execution block allows you to run scripts or other applications on your system, and the web block has the run web JavaScript, which allows you to run arbitrary bits of JavaScript if you need to do something very specific in your application, because some applications are harder to automate than others. Blocks make it easy to get started, and over time you'll learn their nuances. The key here is to keep refactoring the flows so that they get better and better, and you're building up abstraction layers and subflows to help you. I mean, I'll show you what I mean. When I was starting, I hadn't read the documentation, I was just experimenting with the tool, and I had a flow for creating multiple to-dos. And because the create to-do flow is a subflow, I don't really have to worry about whether it's elegant or not. I've just created a flow that does things. And the first versions of this were not elegant. Right, this looks okay. We've got a count, we've got some variables through here, but this is not the first version. This is my first attempt at creating a to-do. This is because I didn't know the application, I hadn't refactored it, but I gradually just cut this down as I learned that I didn't need variables. I could have values that are passing through. I don't have to type text, then do the enter. I was able to put the capture in there by passing in variables. I gradually refactored this as I learned the tool into something that was much better. So now I have something much simpler just by learning the tool and refactoring over time. I just want you to be aware that when you're evaluating the tool, if you create flows that are pretty horrible, it might be you rather than the tool. Certainly this was me rather than the tool, because I was thinking in programming terms and I needed to think more in terms of the blocks and how the blocks are chained together. But this is just learning the tool. It doesn't take long to learn. I've spent about a day learning the tool before creating all these flows and making this video. And I can see just by looking at this flow that I could make this even simpler, because what I've done here is I've merged assertions in with the doing of things. And really what I probably want to do is have flows that do things and then flows that assert on things. So here's a simple subflow that counts a list of to-dos, and here is the flow that uses that and then asserts on it. So by creating multiple layers of abstraction, one that does things, and then asserts on it, I have more control in how I reuse them, and my flows are simpler. So I'm going to show you a couple of things about the find elements functionality. So if I use my get to do at position X flow, the find element is pretty flexible. So I'll also get my count to dos up, because count to dos is using the find element. What count to dos does is it finds all the elements. And you can see here that having found all the elements, we pass the count into an output variable from the subflow and can use it somewhere else. The get to do at position X pretty much does the same thing. Let me have a quick look at this web element. What this does is it says find the UL where the class is the to-do list, then find all the list items. And you can see here that I've got a field here. This is a variable that I can pass in the value to choose a specific version. And you can see here that I've temporarily, for the purposes of this demo, added a field in here. Let me get rid of that so you can see the impact. And if I wanted to add a new field in here, I would do it simply by saying insert token, then add new field. I'll add a field 3 there. And then if I come out of this, I've now got another variable that I can pass into this control. So this is quite flexible. We can add in variables from outside to help us control. And the selector for choosing a web element is pretty flexible. There's multiple algorithms in here. You've got complete control over this. If you want to, you can see the XPath that it's built. You can validate it with the page that's currently open. When you're automating the web, you'll spend time in here making sure that your selectors are good enough. Then we've got all the other ability to just work with the position or the area, pull out the attributes, CSS values. One of the important things here is the timeout. This is for synchronization. This means that we will look for the element and keep looking for the element until the timeout is found. If we find the timeout early, before 1 second, this control will pass on control to the next one. early. So this isn't a sleep, this is a synchronization control that is useful. So this control has a lot of flexibility in helping us work with the web. We can even use it to iterate over all the elements. I've got an example of that in here. This was me experimenting with the tool functionality. So the find element here is finding all the list items, and I'm saying use all the occurrences. So it will iterate over them, and for each web element there, it will trigger this flow. And what we do here is, or what I'm doing here is, I'm comparing it with the current index. So I'm looking for a specific value in that list, but this allows me to iterate over all the items that I've found. And what I do at the end here is I break the execution when I finish that to then go through and pick up the next one. So find element can find a specific item. It can find all the items and process them. We can limit it down with fields that we're passing in here. It's a flexible control that helps us work with the web. Now some web applications, and To Do MVC is one of them, where sometimes we have to drop down to run JavaScript. So tools that give us flexibility to execute JavaScript can really help out for applications that are a little bit harder to automate than just a very simple application. So in my delete subflow, let me show you the To Do MVC application so you can see how this works. So in the To Do MVC application, the way that the delete works is I have to hover over the application, then this button appears. Then as I go over the button, it makes itself clickable, then I click on it. And this is actually trickier than you think because this is actually CSS and isn't the real control. So in most of the tools that automate this, at some point I have to drop down to use some JavaScript or something complicated to do this. In LEAPWORK, the way I do this is I pass in the number that I want to click on, I get that to do. I click on the web element to set focus to it. I hover over it as you would with the mouse. Then we find the button to make sure it's actually visible. Then I'm using JavaScript to click on it. This To Do MVC app is actually relatively hard to automate, which is why I pick it to see how the tools can handle it. But it's just a single line of JavaScript. So that's a very small amount of JavaScript needed to handle a relatively complex application. And this is hidden in an abstraction layer. So no one else on the project that's using the delete functionality will really need to understand JavaScript. I find the support from LEAPWORK was quite helpful in helping me do these kind of activities. And the last thing I want to show you is the data-driven activities. So I have a data-driven test in here. I've chosen a slightly different method to do data-driven, because data-driven out the box has, you've seen some of these blocks, the ability to read the information from a database, or do what most people do, which is put it in an Excel spreadsheet and read the information from there. I wanted something simpler. I just wanted the information in a text file. And so I'm using the command line to do that. And you can see here, I come in, I take the todos.txt file that I have. So very simple todos.txt with 3 values in it. And what type does is it displays the information in the console with each of these lines on a new line. And the command line then iterates over this. So for each line that is output to the console, I then pass the current line, I log it, and then I create a to-do named of that version. So again, this is another control that takes some action and we can iterate over the results of that. Like the find elements will find all the elements and iterate over it if we choose all the occurrence, and the command line can iterate over this if we choose the iterate method. I find that quite useful to pull out all the values from the text file, pass them into the create to do, then having completed the processing of all the lines, I then count that there are 3 items, then delete the item at position 2, then count that there are 2 left on there. So I'm just going to run this so we can see that this actually works. Now the data-driven activities has the HTTP, so we could scrape from websites or we could pull the information back from REST APIs. There's the database so that we can pull information out of a database if that's where our data lives. And we've got the ability to read it in from a spreadsheet, which is a very common way of doing data-driven type test execution. So that's just counting the number of values there. It's going to delete the second. Then our test is finished. And again, it's recorded a little video there so I can see the execution flow if I need to debug it. The other data-driven concept I used in here was demonstrated in the delete a to-do functionality. So here, rather than feed it with a file of data, I'm just using the loop functionality here to say I want a loop from 1 to 5, and for each value in this loop, I'm going to create some text that says to do, then the number, which is coming in here in the field. So first of all, it'll create to do 1, to do 2, to do 3, and pass that into the create to do. So there's a very simple loop in here, which is creating test data for me. Once you learn the blocks and the nuances of how they fit together, you can create fairly complex little flows in there to use the application the way that you need to. So we've covered quite a lot there. I'm just going to run all the flows so you can see the tool in action. I spent about a day playing with LEAPWORK, learning how it works, putting some flows together, creating some subflows, reading the documentation to get a feel for how this thing works. And I created a bunch of subflows that are reusable. They're my abstraction layer, so I can make the execution flows readable for anyone else in kind of English language. They're very easy to plug together so that anyone can come along and create a to-do, create another to-do, get the values from one to-do, delete them. And we gradually build up the execution that we want in the application as subflows, as abstraction layers that we can reuse. And having access to run the JavaScript block meant that I was able to work around some of the hard parts of the to-do MVC application, so I wasn't limited by the LEAPWORK application. I found the chat on the website for the support very useful, helped me understand some of the ways of using the flows so that I could cut down on the complexity that I had added into the flows to make them simpler. And LEAPWORK is aimed mainly at teams that want to automate but don't actually know how to program. So you can do a lot of the automated execution activities without needing to know how to write programming language. So out the box, it can probably help a lot of teams get automated execution going quite quickly. And we can schedule them on an ad hoc basis, a regular basis, and create suites and have automated execution flows run easily. And if you do have continuous integration, you can use the scheduling REST API to trigger the execution of those flows. So hopefully that will help cut down your evaluation of the tool, because you've seen me create things, how they fit together. Remember to join your blocks together with the green flow and have the right data flowing through in the blue flow, and learn the nuances of the blocks using the documentation. And you can find this tool at leapwork.com, and there's a free trial that you can set up to help you learn how to use the application. And all of that is over at leapwork.com.